Okay, having a few sound issues, so let me know if the audio is okay. I've got a little bit of background noise going on here, and I got some noise cancelling, but for some reason today, my microphone seems a lot hotter than it would normally do when I'm live streaming. So that's a little bit frustrating, but it is what it is. Right, good evening. It is what? It's Monday. So tonight we're going to be doing some experimentation with making circuit boards. If you're new to this channel, you may want to have a look at the video library, and you will see that I have made circuit boards a number of different ways, whether that's using the old acid etch method, whether it's using a CNC method, whether it is going out to PCB manufacturers and having professional circuit boards made just like this one, right? So, but tonight, what we're going to be doing is we're going to be taking on a bit of a challenge. Recently, I saw a video from a chap by the name of Stephen Hawes. Stephen Hawes is one of the founders of a company called Actuall. Actuall is an open source company that make the Lumen PNP, the Lumen Pick and Place machine. And that is the machine which is behind me that I built from source to populate circuit boards. And I digress a little bit, but the point of the stream tonight is to test a method for creating a one-off circuit board that uses a resin-based printer to expose a prepared circuit board, or PCB, that is then etched to create a one-off board. Now, I kind of lent away from making my own circuit boards at home for a couple of reasons. One, getting a decent sort of isolation trace on a CNC machine can be a bit tricky. Double-sided boards, which is where I've moved on to single-sided boards. The boards that I make today are more complicated, so they need a second side. So second side on a CNC with through-hole rivets to act as vias, etc. They're quite problematic. Getting the solder mask on, all of that sort of stuff is it's a challenge. And I've focused more on getting my boards fabricated at a PCB manufacturing house, and I don't know, for 25, 30 bucks, I got 5 custom boards that I can then move on with a project with. Well, that's all well and good, but what about in the situations where you need a one-off circuit board, where you're never going to make a second? You don't need 4 extra ones on the bench, and it just has to do for that purpose, right? So, hey, Race, welcome into stream. Hey, Gary T. Yeah, you'll see there was some tests sent in chat earlier on, and that was just to make sure that things were working my side. So right now, I've got a 3D print running that will be used in this live stream. Once that's finished up, we will see what that's for. And I'm not going to go into too much detail because I want to get into the experimentation part of this this stream. I see you, Waffles. I see you. I see you. Thanks for hanging out, guys. Appreciate you. Appreciate you. So, what are we trying to achieve here? Well, I've got a side project that I'm working on for a friend. So I can't really make too much content about that side project. because it's not my project to share to some extent. But what I can do is talk about, we're trying to interface with a piece of equipment which we're not quite sure how to drive. We've got a dead motherboard which is needs to be replaced, and we've got some idea of a schematic. We think we know how it works, but we don't truly know. So what I want to do is create a breakout board so that I can get an Arduino, get another circuit board that does a similar job, that I can send signals to this device and figure out whether or not it's going to work. And I can do that in isolation. Now, I'm probably doing a little bit of overkill in terms of what we're about to do for this project, because I could probably use a Dremel, right? Or even get a Sharpie and draw on the circuit board to create these circuit traces and get it to work, right? Oh, you like the Christmas present? Yeah, my wife got me something. She said my old chair was too tired; it was falling to pieces, so she bought me a gift. I'm very blessed. So here's the deal, right? We've got an FPC cable, a flat ribbon cable that I need to send signals down. Thanks for that shout out, C Waffles. So we've got an FPC connector. It's a 30-pin FPC connector, and we don't need all of these pins, but I am going to connect the vast majority of them up to this breakout. And all I'm going to do is I'm going to break it out to a set of screw terminals that I can then just put a series of fly wires onto here, drive some, common up the grounds, because you always, whenever you're interfacing with something, you absolutely always link the ground wires up, so that when you send a signal, you don't have a floating voltage, and your circuitry doesn't go, what am I supposed to do, right? So I got you a new chair because yours was making too much noise. It was too squeaky, right? No, mine was falling to pieces. Literally, it was molting and everything. It was horrific. So it was much overdue. It was nearly 10 years old, right? So, but anyway, I digress. So we have a single-sided piece of copper-clad board, and what we're going to do is we're going to condition this board so that we can expose a trace or copper traces on here, so that we can then etch that with acid. So I'm hopefully by the end of the stream going to be showing you the end result of this experiment. Now, this is, I want to signpost this early on. This is an experiment. I have no idea if this is going to work. So make of that what you wish, right? Whether that's down to my poor execution or the fact that this is quite an experimental technique. But okay, so let's before we get into the specifics of the circuit, we have to set up the actual job, right? So the first thing we're going to do is we need to treat this. This is just a standard piece of copper-clad board, but we need to make it UV sensitive. And in order to do that, I have got, where have I put it? I have got some UV sensitive material that we can cut and that we can place onto the circuit board to make it so that it's UV sensitive. Let me just see if I can peel a little bit of this. This is old stuff. I haven't made circuit boards this way for some time, right? So I'm hoping that this stuff is still good. So we will do some tests to prove that out and to try and get some exposure times. But yeah, this is UV sensitive. Now, I'm okay handling it out under these artificial lights that don't give off much, if any, UV light. It's not going to expose it, but under normal circumstances, it's kept in this black bag to stop the light getting to it and exposing it, damaging it, right? So how are we going to expose this circuit board with UV light in order to get some traces? Well, there's a couple of ways that you can do that. Historically, what I've done is to use some transparency. So this is an overhead projector. This is, if you're old enough, you'll remember what an overhead projector is. But for those of you who are not old enough to remember overhead projectors, this is a clear piece of paper that you put on a machine that shines your drawing and handwriting on a wall like a projector. And you can print a circuit board on here a couple of times, layer them up so you get your circuit traces. You tape that to your prepared circuit board, and then you put it under a UV light source. Typically, that would be some sort of UV light. But failing that, you can use natural daylight because there's quite a lot of UV coming from the sun. So that typically helps expose these things when you want to go old school, like, you know, even older school than those overhead projector CU waffles, right? I don't think we got surplus capital to do that. Sorry, race. Okay, our 3D print is just finished. Awesome. That works out well for me. Yeah, I used to use them for D&D maps, right? This is pretty old school, right? So that's the first method, right? Where you print either with a laser printer or a inkjet printer, and then you layer it up, tape it on, and you expose it. And that's quite fiddly because, especially when you're dealing with multiple layers, you've got to align them. You've got to make sure they stick in the right way so that you don't like overlap and get sort of weird doubling going on and all of that stuff. This method, detailed by Stephen Hawes, uses a UV resin printer. So that's what we're going to be using tonight. We're going to be using my my resin printer, and that's an awful camera position. I'm going to see what I can do about that to make that a little bit better for you guys. But that little white box behind me, that is a Anycubic Photon S resin 3D printer, and we're going to try and use that to expose the circuit boards. So that's the plan. So first and foremost, before we get into the specifics of the circuit, how we created it, how we get it into the resin printer, I want to do some experimentation to find out what my exposure times need to be for the photoresist. Right, so we gotta set up as if we're going to expose a board. Oh, we're going to set up as if we're going to expose a board, and then we're going to run this through the printer, and we're going to try and figure out how long this needs to be in there before we get a good exposure. So all I'm going to do is I'm going to line this up with my mat, see if I can get some straight lines here. And I'm going to cut a section of this material. Like that. Let's roll this up. Okay, it does look like there has been some exposure on this edge. So what we'll do is we'll cut this fresh and discard. Oh yeah, you can definitely see that. Can you guys make out the discoloration on this edge here? It's not a uniform color. There you go. Look at that. Right, so this part here has been exposed, and it's effectively rendered some of this useless. But actually, I can see sections of this which are good. So I'm not going to just throw this away and waste it. It will get thrown away, but let's give it a use. Right? So let's take a piece that we can see is in reasonable condition. Yep, that's in reasonable condition. And what we're going to do is, yeah, the darker purple. That's funny. So I'll show you how you apply this in a little bit. But I think what I want to do is I want to remove the protective coating, and I'm going to tape this to a piece of white paper. And there we go. There's a little bit of paper. I'm going to tape this to the paper, and then we're going to expose it. And what I want to see is the little squares or some test pieces that we can determine what the correct exposure is. We're going to try a little bit of a scientific method to figure out how to expose this material properly. Now, this material is actually a sandwich, right? It is a protective coating, then a UV sensitive layer, and then on the back the protective coating. So we have to remove at least one of the protective coatings for this part of the test. So the easiest way to do that is to get some tape. Okay, and then what we do is we stick tape on one corner, like so, like that. And then we stick tape on the other corner, like that. And then we just pull apart. And then you'll see it grabs the protective coating. So this side, this is now photosensitive and is completely unexposed. Right? So what we're going to do is try and get this off my finger. There you go. Ah! Don't stick to me. Stop sticking to me. This could be a really silly stream where all you guys do is watch me try and stop this stuff from sticking to me. Right. Okay. So now what I'm going to do is I'm going to tape this down to this paper, and I need to tape over the sticky part. Otherwise that'll stick to my printer and I can't really remove this. Okay. I just want to get rid of the bits that are going to make this stick awkwardly to my printer. So when Stephen Hall did this, he had a lot of hacking to do in order to make this work, because he was using a Formlabs printer, a relatively recent machine, and he had to fake the machine, or fool the machine into thinking that it had resin in it, because it had resin level sensors. There was a lot of hackery that needed to be done in order to make it work. Now, my resin printer is a little bit older, so it doesn't have all these fancy bells and whistles, meaning that I can just freeball this straight into the machine, like so, and expose it. And I haven't really got to worry too much in like hacking the machine, right? So what we're going to do now is we're going to create a test pattern. And I think we should go in increment of, let me think, what's the best increment in terms of time? Shall we go, we'll start with increments of 10 seconds, or is it 20 seconds? Let's go 20 seconds, actually, thinking about it, because I don't know how long this is actually going to take to expose. Right, so here we go. Let's fire up Fusion. Okay, that's loading, and once that is up, we will switch over to that scene. Okay, perfect. Let's bring this down, and let's switch over. So if has anyone done anything like this? Because if you have, let me know, and let me know if it worked, right? So the first thing I'm going to do is I'm going to create a rectangle that represents the screen of my 3D printer, and I know my printer is 80 by 140. It's only a small build area. Okay, let's just register that in the bottom corner, like so. Perfect. Perfect. Good, huh? Right. So now I want a rectangle in here. And let's go. We'll dimension this 10 millimeters by 10 millimeters. And I will dimension it off here by 5 millimeters. And then from here by 5 millimeters. Okay, so we've got a single square, and I'm now going to create a rectangular pattern. I'm going to select my object, which is going to be this square. And we're going to just drag this over here. And let's just bump up the number of copies. Okay, so we go 5 copies. Okay, let's go 4 copies. We'll just bring them a little bit closer because I just want to make sure that I actually capture this, right? Okie doke. So here we go. And let's hit return. So we've now got a bunch of squares. Finish the sketch. Now, I have to figure out the layer height that we're going to be working on, right? So I'm going to load up my slicer from my resin printer, and I'm going to work out what the layer height is, and each one of these squares will be in increments of the layer height. Just waiting for my lychee slicer to load, and then we can get into this. So please let me know if my microphone audio is a little bit off. For some reason, I don't know if I've received I don't know if I've had an update to Windows or what, but coming into my streaming software today, it was a little bit hot on the microphone. So it'd be useful to know if the audio is good or not. Okay, so if I just go to my export, or let's just add a primitive here. Okay, let's go to my export setting, and we're going to go to the resin. The sound is a bit hot. Okay, so I can dial that just a little bit back. Hopefully that's a little bit better. Thanks, Gary T. Right, okay, so if we just edit this a second, number of layers 3, exposure time 30, list speed. All right, so we're going to have to duplicate. We're going to create a fake resin that's going to allow us to control the exposure times. So have we got a layer height setting here? Printer 50 micrometers, 50 50 microns. So is that 0.05 millimeters? I think that's what that is. So let's go with that. Sounds cleaner though. Okay, cool. Good. All right, so I'm gonna quickly run through what I'm doing here. So we're gonna extrude these in increments 0.05. And let's turn our sketch back on. Increment this one by 0.1. This one is 0.15. This one is 0.2. Okay, so hopefully now you get the idea of what I'm trying to do. So each one of these is incrementing by one layer. Zero 0.45, 0.5, 0.55, and then 0.6, like that, just like that. Okay, so now we have our layer heights. Now the problem that we're going to run into is how do we know which one of these is which, right? That's going to get confusing, no? Okay, so the way we do that is we'll create a new sketch. I'm going to create a construction plane here, and I'm going to drag it out across all of these like so. Let's get to the top. And now we're going to put a sketch on this construction plane. And doing so gives me a clean slate. And I'm going to project all of these squares. Okay. And now I'm going to put in some text. And let's just put in a liter. All right, we'll just put in a capital A, make it bold, and let's make it, I don't know, 5 millimeters high, and then we click on OK. And then what we'll do is we'll drag each of these letters onto here, and we'll customize it so that when we get to expose this, we'll have a letter and we'll know how long each one of these actually took. So we can discern something that's not exposed enough right the way through something has been overexposed. We want to see the full spectrum of no exposure or underexposure right the way through to overexposure. So the sweet spot is somewhere in between those 2 points. So what I'm going to do now is I'm going to just copy and paste this text to each one of these squares. So each square will have a letter over it. Okay, and then we're going to select one of those, one of those, one of those, one of those. And this is the laborious bit, right? Oh, crud. And yes, I am using the keyboard that I made in my last video. That yeah, I am rapidly learning how to touch type. Okay, so there are our letters. We just got to customize this now so we have unique values. Otherwise, we will not know what we're doing. Okay. There we go. Okay, so we're going to get a unique letter on each one of these. Uh-huh. And it's going to be really interesting to see whether or not we can make this work. Because if I can make this work for the traces, I'm actually going to have a shot at trying to do this with the solder mask. Now, that's something I've never been able to get to work. It's always turned into like a goopy, gooey mess. Okay, this doesn't have to be super, super precise because this is just, as long as we can tell. Okay. Perfect. So we now have, perfect. We can finish the sketch. And now all we do is we will extrude, we'll select these letters for our test squares. Okay, and we're going to flip it over, change it to an object, select the bottom. Because they all have differing heights and the bottoms are all at the same place, I just select the tallest one and just drop that through. And now we should have letters placed in our tiles. Perfect. So now we need to export these files. Right, we're going to export these files to a location on my device. So let's do that. And we're going to export them. Save as mesh. So I'm selecting the root component. I do know that I'm not sharing my screen. There is a reason for that. So this is the calibration Calibration. Oh, if I take the caps lock off. Way to go, Steve. Calibration. And we're going to stick that. I'm going to put that in my downloads folder. Done. Done, 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 done. All right. So there we go. So we have now got, would help if I select the right scene. We now have got our file exported. And to export this as a single STL file, all you do is you come over to this section here. And if you right click, you can save as mesh. So no matter how many bodies you have in here, no matter how many components you have in here, if you right click the root of your drawing and select to save as mesh, it combines it as a single STL, which irritates the hell out of people when you do that, because you very often can't separate things, right? So here we go. We're going to delete this default cube that we put in here, so we were playing around with. And now we're going to add the file, and let's go to my downloads folder, and we choose our calibration. And let's open, and that pops into our build plate, just like so. Okay. So one of the things that we have a problem with is that that's very interesting. Okay, this is going to be inverted. This is going to be, yeah, this is going to be an inverted. So everything's going to be backwards. But that doesn't matter. Okay. So what we want to do is we want to come into the export section, and we're going to go to the resin. And I'm going to duplicate. Can I duplicate this? Will it let me? Add new resin. Oh, great. That's just awesome. It's now gonna. Why wouldn't it let me just select? All right, I'm gonna just choose that. Add it. Okay. Layer thickness, 50 micron. Perfect. Number of layers. So how many of these have we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we want 12 burn-in layers. Okay, so we want 12. And we said we were going to go 20 seconds per layer, right? So let's go 20 seconds. Perfect. List speed, I don't really care. Retract speed, I don't really care. Light off delay, 2 seconds. Right, so this is just standard normal layers, so I'm not really overly worried about that. So, what do we need to do next? The next thing we need to do is to get a pen drive, because we're going to export. We're going to export our, cool. We're going to export this file to the machine. So I'm just going to pop in I'm going to lose audio here. How am I going to work this? This is going to be a bit tricky. Tricky. Okay, I think I got it. I think I can work it this way. I plugged this in. I'm not using that device, so I plug it in over here. That should work. Oh yes, that works. Like it a lot. Alrighty, so I'm going to turn my anti-aliasing on, and I'm just going to sharpen the details. We're going to export the slicing. So I've got the free version of the lychee slicer. I really do like the lychee slicer, but you know, I don't particularly want to pay for it. If it's a one-off cost, maybe. maybe. But if it's an ongoing thing, then probably not. Because I've got enough subscriptions in my life. Right, so calibration, save, and then we're going to expose. There you go, done, boom. Okay, so one of the things I probably also need is a transparency, because I got a funny feeling. That this is going to stick to the bed if I don't put some sort of transparency down onto the machine. Now the question is where are my transparencies? That is the $64 million question, right? Where are you, Steve Austin? We can rebuild you. We have the technology. Right. I'm just digging through a box of stuff here, which I hope and pray I've got transparencies in. Otherwise, I'm kind of up a paddle without a creek. Ah, yes. Transparencies. I got. My only concern is how much UV light this is actually going to put out. So what we've got to do is to ensure that we use a transparency when it comes to exposing the actual board, right? So we're comparing apples with apples. So I've got a piece of transparency. This may go horribly wrong, but let's see what we can do here. Okay, let's line that up. And we're going to cut it down the middle here. I'm attempting to do a straighter job than I did before, and oh, that's just awful. Doesn't help that my cutting mat's not flat. First, that's the problem. My cutting mat. It's my cutting mat's fault. It's my cutting mat's fault. Shut up! Don't judge me. Okay, so let's just scribe that away. Scribe that away. Scribe this away. Like so, right. Alrighty, let's get rid of our trash so we're not making an absolute mess of things. And now we just got to get our printer up and running. So let me get the camera in a little bit of a better position so you guys can see. Otherwise, this is going to be really rubbish for you guys. And we don't want that now, do we? We don't want it to be rubbish. We want this to be meaningful. We want this to be cool. Okay. This is all sorts of wrong, right? This is so gorilla. Oh dear gosh. Right, okay, let's get you in. This is probably as good as I'm going to be able to make it right now, but you know, them's the breaks. Them's the breaks. Where's my power supply? Of course, it's under the box that I just planted my camera on top of the streamer right here. Okay, so what I need to do now is just power up. Let's switch over to that camera, right? Otherwise, you're going to be just staring at the top down. Let's go there. Right, so you've got a better view of what I'm attempting to do here, and I'm going to plug in my power supply down here. We've got to power up the printer. So the cool thing about this is there's no door sensor, there's no resin sensor, there's no complicated gizmos, gadgets on this. I mean, it does suffer from a lower resolution screen than other printers, and it also suffers from a smaller build volume, but that's going to work in our favor in this particular instance. So we're going to power the machine on, and I'm going to place going to place our UV sensitive or UV coated paper into the printer like so. And I'm just going to place something on here just to keep it nice and flat. Have I got something a bit bigger? Yes, I do. Yes, I do. This is a little bit weightier too. Boink. Okay, so that can just sit there like so. And we're going to take our... It's too late, you've already judged. Thanks, see you, Waffles. Appreciate you, buddy. Okay, so what we're going to do now is I'm going to just plug this in. And we're going to go a little bit candid here, right? I'll try not to make this a bit rocky for you. So here's the menu of the printer. And we're going to go in here to print. We're going to go down to our calibration. And there's our calibration. I tell you what, we might have a problem. I have a sneaking suspicion that if I run this, that is going to crash into that. So I need to swap that out for something else. This manual will do perfect. There we go. That'll work. That'll work. Right. So all we got to do now is hit the print option. And we obviously the head's not on here, right? But then that comes, and that's going to go through a series of exposures now to get, oh my word. Okay, now we don't touch it. Now we don't touch it. So that's now exposing. I'm hoping that that is actually going to see all of it. I don't know whether it will or whether it won't, right? But I guess as long as the sweet spot of the exposure time is somewhere on that unit, all the better, right? So that's the first exposure done, and you'll notice on the next screen we got one square missing. Right, so this is going to so everything's now got 20 seconds. You can see what I'm doing, right? So in terms of the exposure times. Hopefully that makes sense. Has anybody got any questions? So the thing for me is that if I can get a usable breakout board, I can then interface with this device, start sending it signals, and then I can start thinking about designing a more substantial board. And that will probably go to a PCB fabrication house to be made professionally. But as it stands, we're literally just making a bog standard breakout board. So once this is done, and we know our exposure times, we'll start looking at the preparation of the files in order to make this work. Now, I've already prepared these files ahead of time. And the reason I've done that is because some of the workflow, I use a couple of different applications, which I will walk you through. And the Fusion 360 part of the workflow is quite intensive. And the reason that it's intensive is that there's a lot of geometry that's generated, and ideally it needs to be simplified. I haven't looked into how to simplify it. I've just made it work. And that in effect, what happens is it creates... If you've ever used Fusion 360 and you've done a really complicated calculation, you've seen Fusion 360 kind of stutter, go stunned and go, and then you get the black panel on the left hand side, and it's like, is this going to crash or is it going to work? Just don't touch it. Leave it alone, and then all of a sudden it springs to life. Well, that's the situation that that we're dealing with here. I've actually recorded that process separately. When I prepared the files, I've recorded the screen cap of it, so that when I do a produced video on this process, I can truly demonstrate what has been done. But as I say, this there's a couple of different steps, and it took me a while to figure out how I was going to do this. And I think while it's a little bit of a fuss, I think the result potentially is worth it. But we'll see. We'll see. Okay, so we have 4 exposures remaining, and then we can have a look at the squares to see which one of these is the one that we want to use. It's quite interesting to watch this just go through its sequence. So we're going to need to replicate this this calibration again when it comes to the solder mask, because I need to figure out how to expose the solder mask appropriately as well. So that, and that's gonna be a challenge in its own right. But yeah, fun times, right? Fun times. Okay, we got 1 exposure remaining after this, and then we should be good to go. But I'm expecting, if I've done this right, I'm expecting things to be reversed. But again, as I said earlier, my only concern is how UV blocking that transparency is. If it blocks quite a bit, then that's going to be a bit of an Achilles heel, using that as a transition material, interface material. So the reason I put the transparency there was I didn't want the exposed UV material to stick to the screen. If it sticks to the plastic, I'm not really that bothered. I don't really care. There we go. That should be done. Yeah, that is done. That is done. So let's go ahead and take that out of the machine, and we can inspect. Oh, wow. Oh, that's cool. That's pretty slick. Okay, I don't know how well you're going to see this, but let's see what you can see. You can definitely see the exposure. And it would have stuck. It would have stuck to the plastic. Okay, so the question now becomes, which one of these is the most appropriate for our exposure? So let's get the microscope. Let's get the microscope in here. I do need to go to studio mode. And I do need to go to here. Many moments later. Okay, so if I now go to how to work this out. Okay. Sources. All right. Okay. So here's the material. This is where A is. This is where B is. I can just about make out B. And then we get C. But the trouble is you guys can't really see that well. Okay, there you go. You're starting to see the exposure of C. There's D. There's E. Can you guys make that out? There's S. There is G. Now they should be able to make G out. Then H. I. This is awkward to capture, right? J, K. So let me just bring this in real close and see whether or not that makes a. We can get this to show up a little bit better because I can see the contrast in real life. Can you guys make that out? It is real faint, but it's there. Barely visible, right? So we've got to figure out where is our sweet spot. So these are all 20-second exposure times. And we just lose the last one. Is L just there. So, okay. So what am I going to do? I think I'm actually going to go with G. So what's that? 20, 40, 60, 80, 100, 120, 140 seconds exposure time on that. 140 seconds. So let's write 140 down. Now this could be abysmal. So I guess all I want to do is expose it enough, right? I need to expose it enough. And then the development process of the film will take care of the rest, is what I'm hoping, right? So let's talk about how I went about creating these files for exposure. So the first application that I used was KiCAD. Let's open up KiCAD a second. And essentially, with KiCAD, you draw a schematic, which essentially is just a map of the components and how they connect to each other. You then create a board layout. And once you've created I'm oversimplifying. So you create a schematic. In that schematic, you assign a footprint to each of the components, and that can be quite laborious. Once you've done that, you then create your board layout. And the board layup is just here. I'm just figuring out how I can show this. There we go. I can show it like that, I think. I think that will be okay. Right. So we get our board layout. And essentially from this window, we create the manufacturing files the way you would if you were to, say, send your circuit boards out to a board manufacturer. And once you get those files, you could save the traces as a DXF or an SVG, but the problem is each of these traces is a singular line that has width or thickness, right? When you get that into something like Fusion, Fusion has a bit of a problem with lines to give them thickness. They essentially, they're infinitely thin. So that's problematic. So effectively what I need is the lines to be the perimeter or outline of each of these traces. So I thought, how the heck am I going to do that? And I went through a number of different things. I exported as a DXF. I exported as a PDF. I exported as an SVG. And it came down to, okay, each of these export methods that I've used so far all create a vector line at the center of my trace. And then there is some understanding of how thick that line is in a given application, whether it be Inkscape, whether it be Adobe Illustrator, whatever the application, right? It translates that infinitely thin line vector to have a certain amount of thickness, giving it the perception of width of the trace. And that really caused me a lot of headaches to try and understand how I'm going to overcome that particular issue. And then it dawned on me. There is another process that I have used that uses the outlines of circuit boards in order to create a given PCB. And I'm trying to dig out an example of that as we speak from my drawers, which is why I'm kind of rumbling around here in the background, because I do have an example here somewhere. Aha, I find you, I spy you. Okay, and that is PCB milling. So when you mill your own PCB on a CNC machine, you create a series of vectors that the machine traces out. And this is one of the reasons I want to solve this. Can you see the corrosion, oxidation on the copper? That's really bad. Anyway, this is a double-sided board, or an attempt at one anyway, right? So it mills the traces. So hang on, how did I create that? Well, I used an application called FlatCAM. So let me fire up FlatCAM and I can show you what I did to create these vectors that I then went on to use for so many windows. What on earth is going on? Right, so let's launch FlatCAM. So FlatCAM is an open source CAM processor for creating PCB CNC instructions. So you can mill a PCB at home. Bit of a pain in the butt to launch. Takes a little while. Should have thought ahead of that, really, shouldn't I? Okay, so here's FlatCAM. And what I'm going to do is I'm just going to open up the files. The reason I'm being so evasive is because there's there are files in here that the naming convention gives them away as to what they're for. And it's not, I wish I could share more, maybe in the future, but not right now. Okay, download. I put them there. Documents. I got to figure out where I put these done files now. Oh, I know where they are. I know where they are. I'm being an absolute idioto. Okay. I'm almost there. Okay. Bish bash bosh. Open. I'm going to open all of these vectors and then we're going to jump over to the PC. Right. Okay. So here is the circuit board. I've got the edge cuts. I have got the copper fill. I've got my traces. I've even got silkscreen, and I've also got a solder mask. So what I've done here is that to create the outlines, I essentially select one of the layers that we want to process, and we go to where is it? Isolation tool, right? We're going to run an isolation job on this particular, right, so we've got edge cuts, so we generate the geometry. So this traces the inside and outside of that line at a given thickness, because it's going to tell a CNC machine to use a V-bit to create that edge cut, right? And it's the isolation toolpath is it's really important that we use that specifically. So once we create that, we get this geometry file. And then that geometry file I can export as a DXF. The DXF is now like what we want. So each of these files I've exported, and I've included the edge cuts. And the reason I've included the edge cuts is because I'm using the board perimeter to set a standard height and width of the job. And that's going to come in incredibly important when it comes around for us actually running the job on the CNC, on the printer, because we have to figure out how we're going to register the board, especially if we're going to go through multiple operations. So we're going to expose the PCB to give us the traces that we want to leave behind when we etch the circuit board. We want to have our solder mask, and potentially we might want to put on some silkscreen, right? So we need to be able to register each layer on top of itself. We're going to be removing the circuit board from the machine through each of these processes. So what I then did was to bring those files into Fusion 360 as individual DXF sketches, and then I extruded each of these layers out to then create a STL file, very much like we did for our calibration. That was then created so that I can now put that into my, in fact, that's actually a good point. Did I create the correct layer height? I probably didn't. So let's go in and do that, shall we? Let me just open up the file. Come on. You can do it if you really want. Okie doke. So let's go to this scene, like so. All right. So here is what we're seeing here is the That's the solder mask. I think I've messed up. But anyway, I'll figure that out in a second. Okay, so let's get rid of these things, right? Let's get the traces up. So there's the traces. Okay. So we want to just activate this, and we're going to right click. Now this could crash. Oh my goodness, this could crash. So let's see if we can do this without crashing my streaming software and possibly Fusion 360, because there's a lot of geometry, and that's the point I was trying to get at earlier when Fusion 360 was trying to process this stuff. What it's finding, if you look at the corners, in fact, let me escape a second. I'm going to zoom in here. If you look at the corners, you can see the number of points that exist along this curved surface, right? And all of these bends, all of the pads, right? They've all got these sort of flat surfaces and vertices that are in the DXF file that Fusion 360 had to process. If I replicated this and I drew the geometry out in Fusion 360, then it wouldn't have been a problem, right? Fusion would have gone, oh, I know what this is, and boom, it would have exported that, not a problem. The fact that this has got so many geometric points in the drawing just through the nature of a DXF file is what's causing this a problem. So, and it's for a simple project as this is, it's actually quite complex. So we're going to adjust the thickness of this to 1 layer. Here we go. Here we go. Dun, dun, dun. Is this going to crash? This is what I was talking about when you see the black screen appear on the left-hand side. That this is Fusion going, I'm really thinking hard. And you just got to hope now that we don't crash Fusion. That would suck. But we'll see. We'll see. So, just to talk through a little bit about the process that we're about to go through, we're going to get the export of this file to 1 layer height for the circuit. Once we've got that, we're then going to expose the board in the resin printer. We're going to then process the resist so that it takes away all of the photosensitivity of it, and it fixes the exposed area, so it's ready, hardened to be able to be put in an acid bath to etch the copper away. So let's get on with this, right? So this is going to be 0.05 millimeters tall. So that's a single layer height. Okay, so that's the traces being calculated, and then we're going to do the same for the copper fill. This is really good. I mean, this could go bad, right? This could totally not work. I have no idea if this is going to work. It's going to be super cool if it does, though. Is it going to be a little bit of a game changer for like bodging a single circuit board? Kind of like it. I kind of like this, right? When we do the copper fill, it's going to be a lot less. So once we've exported this, what we're going to do is we're going to prepare the copper clad board ready for taking the photoresist or photosensitive material. There we go. That's that one. There we go. Done. And now we do the same for this. This should hopefully turn around a little bit quicker. Oh man, Is this going to work? Oh! 0.05 and hit return. And that should, in theory, be us, right? And then we'll export that and then we'll get to preparing the board. Come on. Why is it that we live in a time where we just gotta have things so fast, right? There we go. Perfect. And I'm now going to select this here. I'm going to export, save as mesh. That's what we're going to do. We're going to save as mesh. We're going to select all of the above. Hang on. Cancel. We don't have the edges. And the edge, of course, the edges are too big as well, right? So let's activate that. And we're going to right-click, edit feature. Hopefully this should be quite quick because it's not so much detail. 0.05, one layer height, and hit return. And then we can, come on, you can do it. Come on, you can do it. Come on. This could be a sign that I need to build a better PC. It's getting to that time, right? Okay, there we go. We're going to right-click this. And for every job that we do now, we're going to include the edge cuts part of this so that we fix the width and the height of the exposure so that we can register this in the same place every single time, which is highly important when it comes to when we remove the board from the setup, right? So, okay, here we go. So we're now going to export this as a mesh, save as mesh. Okay, and I'm going to board test 1. Okay, and we're going to stick it in my downloads folder. So that's done. Okay, so now we got to get to preparing the no, we're not going to prepare that. We're going to prepare the copper clad board ready for processing. Right, so the first thing I'm going to do is I'm going to grab a pair of gloves. Not because the chemicals I'm about to use are nasty, but there will be a point in time that we will be using gloves for that reason. This is predominantly to stop finger grease getting on the surface of this copper clad board, because we want this as clean as possible so that when we apply the photosensitive material, there's no stickiness or any issues being caused by that. Now, I don't know anybody else, but I learned a hack of how to put these gloves on easily. Has anyone seen this hack? Right, the first thing you do, right, you inflate the glove a little bit just to get your hand in. And then you put your first 4 fingers into the glove, leaving your thumb out. Do not attempt to put your thumb in, right? And in goes your fingers, like so, right? So you get to this point. And you do exactly the same with the other glove. I didn't even blow this glove up, right? Because that's how I roll. I'm a living contradiction. Right, so you're now at this point, and all you then do is roll over and stick your thumb in the hole, and jobs are done. How easy is that? How easy is that? That's super cool. Right, okay. Anyway, I'm so sad that I get geeked out by how a method to put gloves on. Like, duh. Okay, so I'm using 99% isopropyl alcohol. I got a lot of it. And the first thing I'm going to do is I'm going to use a bit of tissue, right? And I'm going to just give this a bit of a wipe over with some IPA, just to start the process of like getting the grease and dirt and rubbish off of this board. All right. Okay. So I'm going to toss that away just so I don't contaminate the surface of the board after the fact. And then the next thing I'm going to do is you're going to add some baby powder or talcum powder to your hands to help. Okay. Okay, so now I'm going to use some 120 grit sandpaper, and I'm going to sand the surface of the copper clad board to remove any oxidation that is currently present until we get a nice bright surface. But this takes me back to like high school days when we used to be in the lab creating like circuit boards from scratch. Did anyone else do that? Or is that just me? Okay. I think that's enough. And then we just get some more tissue and some IPA. And we're going to give this a wipe down again just to remove any debris that has been caused. I mean, there is debris on here, right? You're going to get rid of this debris. Like so. All right. No, don't drop it, because you're going to have to wipe it all over again. Okay, and before I put this back down, I'm going to give this area a clean, because I can see a lot of rubbish left. Oh, look at that. Nice. See a lot of rubbish collecting on the bench. All right. Okay. What's next? Okay, well, the next thing we need to do is to get some material that we know is good and big enough to cover this circuit board, and unfortunately that's not going to cut it. There's an exposed patch on it which we can't use, and the same for that. So we're going to have to get some fresh material to cut to put on the board. Okay, now what I like to do is I like to put a little bit of extra. Okay, there's more exposed bits here, right? So I'm gonna have to dance through the exposed bits. So let's put the board up top here, and I'm going to cut, and cut. Okay, I'll have to find those exposed bits a bit later and fix that, right? Just make sure this isn't exposed. Otherwise, that could just be a bad day. Okay, as before, right? This is going to be fun trying to do this with gloves on, right? Because the tape is going to stick to my hands like nobody's business, right? To the point where I may need to take the gloves off, actually, thinking about it, and just be incredibly careful. Where's the end of the tape? Can't feel the end of the tape. It's here somewhere. Don't you just hate that when you can't find the end? Oh, dang it. Oh, and it's ripped the glove. Okay, gloves off. Gloves off for this bit. Just going to have to be incredibly careful handling that. Okay, let's find the end of the tape. that it? No. There it is. I got it. I found it. I done found it. Okay. As before. Okay, so we take our material, we stick a bit of tape in the corner. Let's pick a corner that wants to behave with us, like so. And then we take the other side, and then we pull these two pieces apart, and you'll see that comes away like so. All right, so the next thing we got to do is lay this up onto the board itself with the exposed sides facing down. We cut extra here, so this should fit. If it doesn't fit, I've done something wrong massively. Okay, so now we want to try and remove any air bubbles from underneath the board, and we're going to use where are we? Yeah, let's use one of these, shall we? Which one should we use? We use this one. We're going to use one of my cards. I'll be handing these out at Make a Central this year, so if anyone's going to Make a Central and you want one of my cards, then you know where to come. Okay, so we're just going to remove as many of these bubbles as we possibly can. And now I'm just going to trim this piece of tape. Otherwise, that's going to be an absolute pain for us in a minute when you see what we're going to do next. Okay. Right, so now that's loosely applied. We need to fix this material permanently to the circuit board. And in order to do that, what we're going to do is going to get a piece of paper. All right, let's put the cap on top of the isopropanol, 5-liter isopropanol bottle before I kick it over, because that's always an option for me. I'm like a total klutz. Okay, so we are now going to use a laminator, a paper laminator. We're going to run this circuit board through this laminator. Let's see, will the cord reach the extension? Just. I was wondering if I was going to be able to do this on camera, and now I know the answer. Yes. Okay, so that's now warming up. That's when this light turns green, we will have this up to temperature. And before we get there, we've got to prepare that board so that it can go through. And the easiest way to prepare the board is to get some paper. And we're going to fold the paper, standard piece of copy paper. We're going to fold that in half. Okay. Because this is going to act as a bit of a protective coating as this goes through the machine. So what we're going to do is we're going to pick up our copper clad board and we're going to place it inside here. But I'm going to keep it roughly in the center, so it's not towards the edge here, right? And we're going to feed it this way, so the paper doesn't actually interfere with this surface. So we're just waiting on the we're just waiting on this to heat up. And then once that's done, we'll pass this through maybe 2 or 3 times so that we get a good bond and hopefully we have 0 bubbles, right? Or as close to 0 as possible. This can take a little while to warm up, but okay. So while we're waiting for this to warm up, what we'll do is we'll start looking at processing the we'll start looking at processing that file for exposure, because we're getting close now. We're getting close. Okie doke. So we're going to add the file, board test 1. We're going to open that. And then there is our circuit. Okay, so we need to figure out the orientation of this. Now, bearing in mind, we're looking through the circuit board at the bottom layer. So this actually needs to be flipped. So let's go rotate on plate, and then we select this top surface. That bugger. Okay. We don't want auto orientation. We want on plate. There we go. Let's flipped it over. Perfect. That's exactly what we want. So when we get to the exposure, it should hopefully expose it the right way around. I'm gonna eyeball this before I run it. Okay. So we're almost up to temperature. I can start to smell the machine. These laminators have a very distinct smell. Ah, there we go. And the light has just gone. Okay, so we've now got the lights tell us we're up to temperature. So now we're going to run our board through here. Just make sure everything is looking the way I want it to. In fact, I'm going to run this. Let's get the bubbles out this side. And then hopefully when it runs through, it'll just like peel, like squeegee out all the bubbles. So here we go. Here goes nothing, right? Wish me luck. Let's just hope it doesn't jam in the laminator. Okay, there it goes. As I say, I'm going to run this through a couple of times to make sure that we get a good heat transfer through. Here's the board. And remember, this is a copper-clad board, right? So copper likes to transfer heat really well. Okay, let's do that again. Okay. We'll do it 3 times in total because we want to make sure we get a good bond to. We want to get a good bond to the board, and that's all about the heat generated in that that copper plate. So one more pass should do us. Okay, last pass. Here goes. And then we can figure out whether or not this worked in terms of the application of the material. So remember, we still have a protective coating on the one side of the material, the side facing upwards off the board. So we're going to have to remove that as well. But we won't do that until the very last minute. Okay, you can see that the lights just turned off, and that's to do with the heat absorption of the circuit board. So it's cooled the heating element down. All right, we can turn the unit off. Let's put this down out of the way to go and cool off. We can now inspect. Now, what's likely to have happened is that this board is now stuck to the board, and there are some artifacts in here. There are some wrinkles. So, is this going to work? I don't know. It's like I didn't want to see that. I really didn't. But oh well. We're experimenting. Maybe 3 passes was too many. Maybe it overheated. Maybe it didn't like it. All right, so the board is now prepared. Okay, so that's now photosensitive. So let's go back to our circuit board. So there's our circuit board, and as I said, I'm going to eyeball this before I actually run it. So let us export. Oh. We don't want to do that. We don't want to do that. We cancel. We need to set this up. So let's choose our material. Let's edit. We set 100. We want 1 layer out. 140. Yeah, 140 seconds was our target. Okay, so we export that. No, we don't. We just close that. There we go. And now we export the slice file. So let's grab the pen drive that we're going to be using. And as I say, I need to make sure that this is going to expose the right way round. Otherwise, things are going to be like upside down and inside out. Boy, you turn me. That was so bad. That was so bad. Okay, continue. All right, so this is going to be PCB 1. Okay, we're going to save that. And because that's going to be like 140 seconds worth of exposure time, I don't particularly want to test that, right, on that amount of time. So let's just change this now to 10 seconds. And we'll export another file, yeah, that we can use as our like visual aid to say, is this correct? Is this the right way round? So let me bring up KiCAD and look at how this should look if we have this board being exposed properly. This is the crux of it, right? This is where these little details is where you're gonna like really mess things up if you get this wrong, right? And this will be PCB 1 test. Okay, go. Awesome. For packaging the files, and then we're gonna go over to do a bit of a candid camera again. To see whether or not this has worked. All right, so let's go here and let's go turn you off. I'm gonna go there, right? How many ways to get things accidentally mirrored on the way from the pinout to the data sheet? The problem, yeah, there's the right. There are so many things. Which is why I labeled this stream an experiment, because there is a reasonable chance, there is more than a 50% chance that this is going to go bad, right? So Okie dokie. Let's go enter. Let's go down. What do we got? PCB1 test. If I go up, what have I got? PCB1. Right, cool. So it's the PCB1 test is what we've got. Let's have a look at what this looks like when we expose it, right? So I'm going to hit the go button, and we're going to see the PCB as it's going to get exposed. So this has to be reversed to what the board's going to look like, right? I gotta figure out if this is right or not. Okay, here we go. It's going to home. It's going to plunge. And then it's going to expose layer 1 for 10 seconds. Here we go. 1. Okay. So let's quickly have a look at KiCAD. Oh my gosh, is that going to be right? Is that going to be right? I don't know. So okay, so here's the board, right? That's the bottom side of the board. I think that's going to be okay. I think it is. Should we just do full send? Let's do full send. That's what I think. Right. So before we do that, I got to show you what I was printing at the beginning of the stream. Now, those of you who are familiar with resin printing know that there is a bus that the resin printer has that contains all of the resin. Right. This is where all the printing takes place. Look at how bad that FEP sheet is. Oh my gosh, that so needs changing. So we're not going to be using the vat, but what I have made is something which mimics certain attributes of the vat, namely the two, like the side posts where the screws locate the unit, and this section here which represents the screen. So what I'm hoping I can do is I can screw this down, and this becomes a registration jig that I can place the circuit board into and register it on the one edge, so I can put the board in the same place repeatedly over and over again. That's the theory. Will it work? That I don't know, right? So the first thing I need to do is to get me a piece of clear plastic that I can put underneath the underneath this jig, so that we replicate the conditions of the test. So let me align. This is difficult because this is clear. Okay, so we align there, and then we're gonna align here like that. And no, we don't. Nearly, Steve, nearly. You nearly messed that up, didn't you, mate? Come on. Sort it out. Okay. So it's that's what I want to do there. And let's go there. So there's a little bit of wiggle room. Now I've got a line that I can cut from. Okay, so let's be very, see if I can actually cut a straight line freehand. And the answer to that is no. No, I can't. Oh, I'm rubbish. But that's kind of the point, right? Because if I can do it, that means anybody can. Right, okay. Go, microscope. Go, gadget. Right, I haven't even tested to see whether or not this is going to fit, right? So I'm hoping it's going to. Oh, look at this. Look at this. What are those? Oh, that's just awesome. Look at that. I'm sorry. I just gotta gloat a little bit. I just gotta gloat a little bit. Look at that like jig. That's proper. Oh, sorry. I couldn't help myself there for a moment. I needed to bask in my glory because getting things right first time out of the gates isn't always what I'm known for, right? I'm usually the guy that fails first time, learns a lesson, goes to school on the first example, and then has to iteratively change course until such time as I force the universe into submission and give me a success. So that jig is now in place. That's pretty slick. Okay, so next, what's next? Next, we have to overhead, Steve, come on. Okay, next we got to remove the protective layer on the unexposed side. So, in fact, I only needed one piece of tape, didn't I? Okay. Okay, so all we do, like we did before, we place the tape here and then peel back, and it peels off the protective coating. Okay, so I'm going to pick up a Sharpie. You'll see why I picked up a Sharpie. In fact, let's get the fat tip, large tip Sharpie, and let's go over to the printer. This is where the rubber meets the road now, guys. This is where we find out whether or not this process is going to work or not. So I just want to run that test again because I want to see the alignment with the jig. Okay, so the head is moving down. And we're about, here we go. Come on. So this is where I'm figuring out my registration. Okay, I'm probably going to run that once more. Okay, I'm just going to check my registration marks. Okay. So what I'm going to do now is I'm going to place my board in there. I want to figure out whether or not if the board is placed here, will it work? And the answer is no, because I've got quite a large overlap of probably 18 millimeters looking at that, roughly. So I'm going to need to move the circuit board over by a set amount. So I'm going to need something that I can use as a bit of a spacer off of the one side. And I'm looking for something that has a consistent width that I can potentially use as a makeshift spacer. And at the moment, I'm not finding anything. Actually, I think I just found something. So these are fiber. These are fiber plates for a jazz bass guitar pickup. So these have been specifically cut. I can pop that in this corner as a registration. And now I should be able to place this in here like so and hit my marks, which I kind of do. This one edge it's going to clip the one edge a little bit, but I'm not overly worried about that to some extent. Right, so let's get this in position and get it up against there, nice and tight. And now what I'm going to do is I'm going to put a pen mark on this bottom corner so I can know which way round I actually put it, right? So now it's time to expose the board. Here we go. Here goes nothing. This is where the rubber meets the road. So worst case scenario, if this doesn't work out right, what we're going to do is going to need to remove this coating and reapply it, which is a pain, right? Because it's all of that preparation work to get to this stage to realize you stuffed up, Steve. So fingers crossed I haven't stuffed up. Hopefully I've done it right. We'll soon find out. So we're exposing that layer right now. Oh, this is exciting. This is exciting stuff. So as long as we see a good exposure, the next phase of the process is going to be that we develop that pattern and turn that exposed unit into something which is etch resistant. So it's going to be very interesting to see. And there's a couple of boards here that I need to make. If this works, it's going to be flipping awesome. I can't wait to see the result of this. And the clock is ticking. How long we got left? Say it's 2 minutes worth, but ooh. So let's just have a little poll in chat. How many people in chat think that this is going to work? And how many do you think it's going to fail? It's going to be interesting to see what your thoughts are. Okay, that's exposed. Just let it do its thing a minute, and then we're going to... Everybody's non-committal. You're right. Here we go. Let's take the board out and let's see the result. Okay. Well, I'm looking. But I'm struggling. I don't see a circuit. That's a little disappointing. I might see something, but it's nowhere near. It's showing the purple, right, Gary T? You kind of hit the nail on the head there, right? There is something there. Okay, so I'm going to do another round of exposure, right? And we're going to see whether or not a second run at this will give us a better result. So this is why we need to be able to register things accurately. Okay. Because then we can repeat the exposure, knowing that the part is going back in the same places that it was on the first time. Now I'm just going to need to make sure that that light actually does come on. Yes, it does. Okay, so we are exposing the board. So what could be causing this? It is a little bit like that, isn't it? Where you got to kind of squint and you got to hold your phone in your mouth and look down at the screen, and it says, "You look like an idiot." Okay, so that class didn't yield anything that I could see. So what could be the reason for that? Okay, so the first variable that we've got going on is that when we exposed on the paper has a white backer. So that means that the exposed result, which you can see a little bit better on here, right? You can see these squares. The exposure result effectively as a contrasting background, which may have helped the exposure actually take to the material, right? So there's that, right? So there's that. The second thing that could be going on is that because of the white background, it has given me a false sense of how long it needs to expose the circuit, because the contrast is that much higher with the paper. The copper clad doesn't have that level of contrast, so you can't see the circuit traces, because the copper clad is not as contrasting as white copy paper. So Okay, so that's then a second exposure. I'm going to do a third exposure, right? I'm just going to hit the cancel button, enter, and I'm just literally going to run a reprint of that exposure. So we're going to do, so this is a total of 3 exposures to the copper clad board that we've treated. So it's trying to, to be fair, when we exposed that first piece of material, it was on a piece of copy paper, not a copper clad board, right? So there's the first variable. Now it's trying to interpret results into something meaningful. The results, I mean, here's the results on copy paper, right? We clearly get an exposure. It was quite difficult to see, but you guys can surely see that on this camera way better than we saw with the microscope. The microscope, you really struggle to see the contrast between the letters. But it's definitely there, right? I did say at the time that I can see the exposure better than you can on the microscope. So yeah, that's a little frustrating. That is a little frustrating. So the copper, I'm not overly worried about the copper traces too much. And I think this board is dumb enough that if I have got it rotated the wrong way, I can probably get away with it. I'm just looking at this right now, and what can I do? Might have to remap the pins a little. Oh, no. If it's not good, if it's wrong, it's wrong. Oh no, I got a funny feeling it's wrong. I have got a horrible feeling that it is wrong. I'm just looking at this mapping now. And I've got a horrible feeling in the pit of my stomach. I'm just looking, this square pad needs to be at the top. Okay. And I don't think it is. I think it's at the bottom, which means it's the wrong side of the board. Okay. Now we're starting to cook. Now we're starting to cook. So that was 3 exposures. And this is what we're getting. You're starting to see the emergence of a circuit, right? And do you know what? It's right. I'm looking, and the square trace is correct. The square trace is up here. Of course, I'm looking at it reversed, and it's on the bottom. So when I flip it, See, with me, I'm second guessing myself. Okay, so looking at this, I think it needs maybe another 2 exposures. So I think that's what we're going to do, is going to run another 2 exposures on this. Bringing us to 5 exposures in total. And then we're going to attempt to develop the board. Oh, that's a relief. That is a relief. Right. So I'm going to put you back over to this screen. I'm going to just prepare some warm water for us to start mixing up some solution to expose the board. Sorry, not expose it, develop it. So I'm just going to go mute, and I will be back momentarily. Okay, that's just raising up. We'll give it one more exposure. So that'll be 5 exposures. So while we're doing that, let's prepare the developing solution. And try and avoid dropping my bag of heat shrink all over the floor. Let's pop that over. Okay, so to develop this material, we're going to be using some Oxy Plus stain remover. I did some research way back, and I found that the ingredients in this stain remover will develop my circuit board, and it's used for washing clothes. So you can handle it. It's pretty safe to handle. Well, as any other detergent would be, right? So just gonna put some of that in here, and then we're gonna just give that a stir to dissolve it, and that's all it is. Done. Okay. And the beauty with this part of the process is all of the things that we've dealt with so far, we can just toss in the trash or put down the sink, you know, for drainage. When we get to the etching part, then that changes a little bit because we're going to be using ferric chloride to etch the circuit board. And ferric chloride is pretty nasty stuff. Okay, I can still feel the grains of this at the bottom. I am doing, well, not copper plating. I'm doing the opposite of copper plating. I'm actually removing copper from a copper-clad board. So what we've been working on tonight is an experimental method of exposing a circuit board for etching. And we're using my Anycubic Photon S resin printer to expose a circuit board design onto a copper-clad board that has been coated with a UV-sensitive coating. So we're just finishing up the exposure. I'm hoping when I pick this up, I'm going to see a nice, clear, vivid circuit board. I mean, I'm seeing something. Is it nice? Is it clear? Is it vivid? Well, I guess you guys can be the judge of that. So this is five exposures at 140 seconds per exposure. Let's get this up close so you can see. You can definitely see the circuit board. You can definitely see that. So this is the correct orientation. You can definitely see that. So what we're going to do now is we're going to develop this so it's no longer UV sensitive, and those exposed areas, in theory, should turn a dark color and be good for etching at that point. So let's bring the camera over so you guys can get a closer view of what it is that I'm doing. Just make sure we're good on battery. Oh yes, I'm glad I plugged that in. All right, so let's go here. So as I said, this is safe to handle because it's all it is detergent for. This is good for, like, it's a fabric stain remover, right? So resin printer is a good idea. Have you ever used a diode laser? I don't have a diode laser. I have attempted to use a CO2 laser because I have one of those, and that was, even on this last setting, was way too aggressive. Way too aggressive. So what we're going to do is going to submerge this in the stain remover, and the ingredients in the stain remover will cause this to no longer react to UV light. Let's drop that in there. And we're just going to allow that to soak and develop. So the non-exposed areas will dissolve, leaving behind the resist that we've just laid down. So I'm just going to give this a little bit of a nudge. You can start to see bits of blue floating on the surface of the liquid. Let me just zoom in for you. Right, you can start to see like bits of blue floating as the process starts to take effect. So I'm not going to scrub at the circuit. I'm just going to allow the material to just dissolve away. I wouldn't mind trying a fiber laser to see whether I could etch a board using a fiber laser. But yeah, this idea I got from Stephen Hawes, who is here on YouTube. He is the founder of the open source company called Opulo, and his company makes the Lumen PMP, which is a pick and place machine, which is just behind me. Currently at the diode laser, pondering a fiber variant to a blade copper works better to burn mask away instead of expose it for development. So, from what I understand, using the fiber laser for FR4, which is a type of circuit board material, substrate and copper, that essentially is a little bit too aggressive. Okay, we've got a development, but not the development that we want. Okay. So it would appear that we're underexposed. I'm just wiping away with my finger the exposed material. I don't know if you can make this out, but all of the material is coming off. That is a little bit of a disappointment. Okay, so what we're going to do is I'm going to set that aside. I'm just going to get the remainder of this material off. So there's two options here: either that the material, the photosensitive material that we've used is bad because it's old, or we didn't expose it long enough. And I'm going to go down the road. I'm going to say that we didn't expose it long enough. Maybe a UV fiber laser. They seem to be very good at not being as aggressive. I have access. I have access to both of those technologies. So maybe. Oh, it's right. Okay. So there's areas here that are starting to get to the exposure level that we need. I think we probably needed to do a few more passes. So it looks like the UV light is not strong enough to it's not strong enough to get this to cure the way we need it in the number of passes that we've got, right? So yeah, that was getting close. That was getting close. Okay, let me show you up close. So there's areas of this board, you can just make it out, right? There's areas of this board that are starting to cure. So it's a time thing. It is definitely a time thing that we need to fix. Right, let me just clean up my mess. And what we'll do is we'll clean up this board. We'll try again. We will try again. We'll try a better application of the material, and we will try a better exposure. But at least we know the file is good, right? It's producing a circuit board in the correct orientation that we need it. So there's lots to take. There's a lot to take away from this, positive wise. Yes, it didn't yield the result we wanted first time out of the gates, but I mean, we've only had one success with the jig that was perfect out of the gates, so we can't expect to have two now, can we? That's just being greedy, right? So let's just clean things up here, and then we'll go again. We'll go again. Any suggestions from chat what we should do differently for the second attempt? So I think the first thing I would like to suggest is finding a fresher piece of the material, maybe going deeper into the roll, so that we can identify what was the exposure time. It was 140 seconds, and we did five passes at 140 seconds. And it's a 405. Well, if you know anything about resin printing, it's a 405 nanometer UV LED. Oh yeah, that was curing. That was definitely curing, because it doesn't want to. It does not want to come off. So essentially, I've got a single file, a single layer file. I'm just going to sand this off camera a second. Yeah, I've got a single layer file. Which we just tune the resin, the type of resin, for how many layers that we want, how long that first layer actually is. So that's how we're defining the actual time that it's taking. Okay, so let's come through here with some IPA. Give this a clean. I'm going to hold it by the edges. I know last time I wore gloves, but I'm speed running this a little bit because we're coming up on time quickly. So okay. Yeah, well, that's the problem, right? With copper, copper is incredibly heat conductive, right? So I think that's the challenge: is how do you do you strap a massive heat sink to the material so that you let me just cut these pieces away. All right. I feel bad having to throw that stuff away, but it is what it is, right? Let me just hold this up. Yeah, there's been some light bleed. There has been some light bleed into the edges of this. Right, so while we're waiting, I'm going to turn the laminator on while we're prepping this up. And then we're going to just select a section, and I'm just going to cut freehand around here. All right. Take 2. Let's see if we can do this. Yeah, I mean, like I say, this is old material, so there's an element of that going on here. Things do degrade with age, as my body will contest. Okay, so there we go. I've gone and done that off camera, and you can't see what I'm doing. So it's quickly stripped. I put two pieces of tape together facing each other, and I'm pulling the protective coating away. And now I'm going to place said coating face down onto the copper clad board, like so. Or I'm going to just try and smooth out as many of the air bubbles as I possibly can. Air bubbles are the enemy. That's pretty good. And we're going to take a fresh piece of copy paper, and we're going to fold it in half lengthways, widthways, sorry. So top to bottom, like so. And then we're going to place this inside here, like so. Oh, that's just great. You can just hang out there if you want. Okay, so let's just okay, so we'll fold it over like that, and then we're going to feed it into our laminator this way. Once the laminator comes up to speed, which it literally has just come up to speed, we're definitely speed running this. Instead of the 3 passes that I did before, I'm just going to do 2. So let's go ahead and feed this into the machine. And I'm feeding it this way so that the fold of the paper doesn't interfere with the board in any way. So the fold is here on this edge, and then it's going in this way. So I've had it where I've tried to do the fold, and I put the fold in front way, and the paper creases, and it causes all sorts of problems, right? Theoretically, you could actually use the UV resin and a thin piece of release film. How do you mean? Yeah, there was. So Stephen Hawes did suggest that you could bolt the circuit board to the bottom plate of the resin printer, and then just bring that down to the screen and expose it like that. Okay, we're going to see how quickly we can get through this. So we do 2 passes here. And now we've got to figure out how long we're going to expose this for. It was 5 passes at 140 seconds. So my math is rubbish. 140 seconds multiplied by 5 equals 700 seconds. So it's that 10 minutes. That's about 12 minutes, right? Okay, so we still got the wrinkles, right? We still got the wrinkles going on. So maybe just 1 pass would have been good enough, but you know, we're here now. We're here now. I'm gonna still see if we can process this until such time as we get the result that we deem as acceptable, right? So I'm just going to slice this. So the whole purpose of putting it through the laminator means that it bonds to the copper clad board. Okay. Okay. So that board is now, quote unquote, prepared. So we've got to figure out how long we want to expose this board for. Because if 10 minutes was only just touching the surface, right, how long do we really want it to be? We could go 15 minutes. That's 900 seconds for that layer. So let's do that. Is that going to be enough? Don't know. Don't know. But like I say, I was hoping that the tests that we did would have yielded a better result, right? But it is what it is. It is what it is. Right. Okay. So let's go to here. We're going to change our resin settings. We're going to edit. No. We don't want to do that. We want to edit here. And number of layers 1. Exposure time, we're going to say is, how long did we say? 900 seconds. If it will let me. Yeah, 900 seconds. Click on OK. And we have a single layer now at 900 seconds. Let us eject our pen drive and let's export the file over. Okay, and let's go ahead and export the slices. Okay, wait for this 30 or 15-second ad to just go away. No, it doesn't. So, does the question we've got here, does the layer thickness affect the power of the UV light in programming? Where is the power of the UV light fixed? Okay, let me just go into exporting this. We'll go test number 2. And that's then going to export that. That's done, dusted. Okay, so if we go into the settings of the resin, okay, and we go edit, if you look through here, there is no statement of LED power, right? So there's only number of layers in the burn-in layers section. So early layers have to be over-cured to stick to the build platform. They are called burn-in layers or bottom overexposed layers in the other slicer applications, right? So how many layers do you want to burn in, and how long is the exposure time for those burn-in layers? So we say we want 1 layer, because we've got a 1-layer print, and we want it to burn in for 900 seconds. You go through all of the other options here, and there is nowhere here that it states that the LED is changing in power, right? So the only variable you can play with to effectively adjust power is the exposure time in general, right? So here are the possible outcomes. Well, the possible outcome is that we expose this better than we did the first time around, or the first attempt, at 5 rounds at 140 seconds, which is about 12 minutes. So with that said, we also went deeper into the role of material, the UV sensitive material. So if indeed that it's aged and the outer layers have degraded over time, then this is going to be somewhat problematic because we're going to overexpose this board, because this technically would be more UV sensitive than what was on in the middle. So this is a bit of a hit and miss sort of attempt here, right? This could work, this could fail badly, but we won't know unless we try. That's the whole point of experimenting. So now we've got to remove the, in fact, I'm going to try something. So if you recall at the very beginning, we had the UV, we put a piece of plastic on the printer. Right? We put a piece of plastic on the printer so that it would not stick to the print bed. Well, that's obviously going to be blocking some of the UV light. So I'm going to remove it in favor. Let's lock this back down. In favor of keeping the coating on the circuit board. Right? I'm going to keep the plastic coating on here and only remove that once we've exposed it. That's what that white plastic piece is. If you look there, I've actually 3D printed. Let me just get this all framed up nice. We're all zoomed in. So you see this plastic piece here. This is a 3D printed jig. So I've got a little offset off this one side, and we can now plop our circuit board on here. Let's make sure we orientate this perfectly, because if we do take it out and want to expose it for another run, then we're going to need to be able to do that. Right, so let's go ahead and run this. Yeah, I mean, I took the coating off and then put the plastic on, which the plastic is slightly thicker than the coating on the material, but that's not what we did in our calibration test. So I wanted to do like a like for like comparison. So let's have a look what we got here. PCB board test 2. Here we go. So this is going to go off, and it's going to do its thing. 900 seconds exposed. Make sure we're good. It's not going to go anywhere. All right. So 900 seconds later, we're going to find out whether or not this is going to work. So fingers crossed, fingers crossed. And we're yet to etch this. So we've got time to get this exposed and developed, but we don't have time tonight to actually etch the board, which is a little bit of a disappointment, but it's so I'll document all of this in into a video. So if you're new to the channel, feel free to hit the like button and hit the subscribe button if you want to see the results of this experiment actually turned into a video, because I'm going to keep playing with this until such time as I get it to work. So I might reach out to a buddy of mine who's got a variety of different lasers, ranging from CO2 lasers, RF lasers. We've got fiber lasers. We've got UV fiber lasers, and we've got the mother of all UV fiber lasers, capable of cutting up to 18mm mild steel. So yeah, that would be kind of cool to see some of that kit in action. Let's get tidied up here, because we are rapidly getting to the point where we're going to be figuring out if this is going to work. So while we're exposing this, what is the confidence factor in the room around whether or not this is going to be successful or not? And if this was you doing this, what would you do differently to the way that I'm approaching this challenge? And you can't say use a board manufacturer. You can't say use a board manufacturer. So what's your thoughts, guys? Tell me. This is where we endure the wonderful world of chat delay. But yeah, I would definitely like to hear what you guys think in terms of thoughts. No thoughts. Okay. So I think personally, I think we should get a deeper exposure because there are two variables that we have changed in this attempt. The first variable that we have changed is the thickness of the material between the screen and the copper-clad board. Where before we had maybe an 80 micron piece of plastic, we are now like running a really super thin piece of almost like saran wrap, right? Cling film. That so that's significantly decreased the thickness of material between the screen, the UV light, and the material that we're exposing. The second thing is obviously we've increased the time of exposure. So it's going to be interesting to see whether how those changing those two variables affects the result of the exposure. So you would try to print out a clear film, maybe an image that wants to use a pocket UV light or some other UV light source, but this is theoretically the best way. Yeah, so I have done, so there is a video on the channel where I have used the printing technique, and I used some I used some of this material. Yeah, so this is a transparency film, clear film that you can put in an inkjet printer, print it out your circuit board. The only problem with that is that you do have to print multiple copies of it in order to get a thick enough coverage of the material to create a completely opaque covering, right? When you put the print under the microscope, there's gaps. There's like series of dots that you can see where the ink resolution, the head of the printer has a set resolution, and you can see the dots of ink, and you can see gaps. So when you are far away, it doesn't look like there's any sort of spaces between those dots. It looks like a solid line. And probably on paper, what happens is as the ink hits the paper, capillary action causes that to spread, and those gaps are smaller. Whereas on a transparency, there's got some sort of coating to keep the ink in place rather than just smearing everywhere. Those dots are more defined than they would be on paper. I suppose you could probably get better results with a laser printer, but I don't have a laser printer. So the method I used to expose the board previously was to print multiple copies of the circuit with registration marks in the corners, cut that out and then stick the transparency layers and layer them up, so that the line, the gaps in the where the ink has gone over like 2 or 3 of the instances of the board, like printout, it masks off all of those areas, so you get a more consistent blackout of the UV light. And then I use the standard daylight to expose the board. That it's quite surprising how effective, even on a cloudy day, quite surprising how effective using just standard daylight to expose the material actually is. It's quite. I don't know if you know people realize that UV passes through clouds reasonably easily, which is why if you're a construction worker and you're working out on site in the open air on a cloudy day, you can actually get sunburnt. And I've actually experienced that myself. I have been sunburnt on a cloudy day. So yeah, it is something where, you know, low tech can actually work pretty well. So yeah, there's that. The other option that you've got is, rather than using a UV coating to mark out the circuit board, what you could in theory do is screen print. You could screen print to that, right? There's a diode laser exposed that type of film. Well, it all depends upon the light frequency of the diode laser. If the diode laser is in the UV range, then I would say, yeah, probably would. The question then becomes is whether or not your power rating of your diode would be sufficient. It's got to be in a sweet spot, right? It's got to be in a sweet spot of being able to expose the coating, not destroy it. So you could, in theory, like spray paint the copper clad board, let's say with black paint, and then use a CO2 laser to ablade, get rid of all of the isolation traces, right? So it creates the isolation. But I've not had a great amount of success with that. Because copper, as I said before, is an incredibly good transfer of heat, right? Which is why it's used in heat sinks. It's a preferred material over aluminium heat sinks. You look at the stock coolers that you get with CPUs, and they're typically aluminium fins. They might have like a copper die in the center. But you go to a more premium type of product, and you typically find that they are made completely out of copper for the reason that they're good at conducting heat. And that's the problem. You hit copper with a laser, it generates heat, which is great that it ablades the material. But what often happens is there is bleeding of the heat away from the target area and causes a problem with especially with fine traces. It pretty much destroys fine traces. Even on the lowest setting on my 40-watt CO2 laser, I struggled to get anything worth even bothering putting near an acid bath to etch. So that was a little bit frustrating, but it is what it is. It says it's still stuck at 15 minutes on the clock. So what I'm noticing is that clock doesn't actually tick down. It's probably more along the layer lines. So, do not do the full process removing the copper, but just removing the coating. Yeah, that's my point. That is exactly my point. You can't ablade copper with a CO2 laser. There's just that the laser doesn't have the right frequency, and it doesn't have the power to ablade copper, where a fiber laser probably can, right? The problem with doing it with a fiber laser is that you destroy the substrate that the copper is bonded to. So that's why it's, you know, getting it in the sweet spot where you ablade the copper and not destroy the substrate that it's sitting on. But just trying to remove the coating is a particular challenge. Now you might fare well with a diode laser with a painted surface, because a diode laser isn't as powerful as a 40-watt CO2. The way I think of it is a diode, and to be fair, a lot of the diode lasers are getting way better. Some of the etch tool stuff that I've seen is looking pretty sweet, right? But I haven't actually got under the hood of that technology to see, is it a diode or is it an RF? Is it an RF laser? RF lasers, you don't have a tube. You don't necessarily need the water cooling that you do with a CO2 laser. The package that, the whole package for a like-for-like RF versus CO2, theoretically, you could have a K40, a small, printer paper, copy paper size work area laser cutter that's 90 to 100 watts using an RF laser, because the CO2 lasers are defined by the length of the tube. The longer the tube, the higher the wattage. RF lasers, not so much. Not that I would want to put an RF laser into a K40, right? You need to pulse the laser. Yes, the vast majority of lasers are controlled by pulses, known as PWM, or pulse width modulation. And there is a duty cycle. There is a minimum duty cycle that a CO2 laser needs for it to actually fire. And I got that. I think the lowest I've seen it fire on mine is around about 9%. And even that lower, PWM duty cycle, it's still not usable. I've tried. I've taken it all the way down to the lowest setting that I can on my CO2 laser to the point where the laser has partially failed in actually firing, because the PWM signals are so low it can't actually trigger it. So I've taken it all the way to the bottom, and even that level, it's still not something that I can use in my experiments with my machinery. Your mileage may vary because you're using something different potentially, right? So vaporize a minute piece of copper before heat gets to bleed away. Yeah, you could break it down into jobs like that and introduce some pauses into the work, I suppose. The other way you could possibly do it. Now, this is an interesting idea. If you bonded or stuck the copper plate to a Peltier, and you water cooled the Peltier. So a Peltier is a device whereby if you apply power to it, one side of it gets hot and the other side of it gets cold. And Peltiers are often used in sort of extreme overclocking. If you're into PCs, right? Peltiers are used on the main water block or main heatsink of the CPU, and you essentially cause a cold barrier on the underside that's touching the die of the CPU, and the other side gets hot. And you typically water cool the upper side of the hot side of the Peltier to just drag the heat away from the Peltier as best as possible. The other way you can use a Peltier is if you heat it up, you can actually use it to generate electricity. So that's a really unique property of the Peltier device. It works both ways. If you heat the one side and you cool it, you can actually generate power from it. It's quite cool. I believe wood stoves that have got a fan on them use the Peltier effect to drive that fan. Okay, we have exposed the board. So what do we think? Do we think this has succeeded? I'm gonna have a look, and I'm not gonna tell you. I want to see what you guys think. Did this work or did it fail? Did it work or did it fail? Can I see how good my poker face is? I'm going to give you guys a moment, and then I'm going to show you. This chat today kills me. Okay, I gotta show you. I'm gonna show you. Here we go. Here we go. Here we go. Here we go. Look, looky. That's pretty nice. That you can definitely make the circuit board out quite easily. So that's very pleasing to see. I'll give you a bit of a closer look. On this camera. See if I can turn it to get it to contrast for you so you can see. In fact, I'll zoom like that and then I'll bring it close. That might work a bit better. So that's actually exposed pretty nicely. So we're going to try and develop that now and see if, let's see if it takes. Because there's still opportunity for this to fail through the developing process. Okay, so we're going to take the protective coating off this now. Like so. And now we're going to bring the vat of detergent back. And we're going to try and develop this board. In it goes. Just dropped it straight in. It does look promising, doesn't it? It's I just hope that was long enough and that this board just develops. Okay. So again, this is just a detergent for clothes, for a stain remover for clothes. So it's actually safe to handle. As much as any detergent is, right? If you have a particular, it's not like lye or anything like that. Drain cleaner, but it's a fabric cleaner. So I'm just gently wiping this over with my finger to try and aid the removal of the unexposed material so that I keep this in this vat the shortest amount of time, because I don't want it to start attacking the area that we have exposed here. And I have a funny feeling that's is that coming off, or is that my eyes? I don't know. I'm hoping this is just exposed material just... Okay, it's looking all right, I think. Oh my god, I don't know. If this doesn't work out, I'm gonna have to review my process. Just make sure I got the sequence correct. Because I think this is pretty darn close, right? This is pretty darn close. Yeah, I'm going to need to review my process, I think, because I'm not convinced that the copper trace is a... I don't know. Yeah, the traces seem to be breaking up, so I don't know if I may be going about this wrong. I'm going to review my old video and just make sure that I'm actually doing this in the correct sequence. I get the sense I am doing it in the correct sequence, but the exposure, I think the exposure duration is marginal. I think it's marginal, and that with a bit more exposure time, we could be on to something here. Yeah, because I can see some of this stuff is coming away. It's destroying some of the detail. So I'll bring this up to camera in a second, and you can have a look. Because lye is the last. If I remember rightly, lye is the last process. Lye will actually bring up this coating. Right. Let me just dry this off and give you guys a view of it. But I personally think we're on the cusp of getting this perfect. Right. I definitely think we're on the cusp of getting this perfect. So that's where we're at. Okay, so what I'm noticing is that these large areas of where this material is sticking, and there are areas whereby that it is obviously it's breaking away. So it either hasn't adhered to the board properly, or it's a case of the material is... That's interesting. That looks way more exposed than the other parts. Huh. We got a hot spot? Is that a hot spot on the LED? That's intriguing. But that's okay. So first and foremost, this is a significant improvement, right? Yeah, I think you're correct. So I wiped it off with isopropyl alcohol before we etched it. Oh, sorry, before we exposed it. So I'm wondering, do we give this another shot? I think we're incredibly close. I think we are incredibly close. So let's clean the board off. Have I got the ingredients for what I would like to do? I don't know. I am looking for some. I'm looking for some lye. Have I got lye up here? I don't. I used to have lye up here. I don't think I have any more. No. Now it would appear I do not have lie. Okay, let's see if I can. Let's see how it. I wonder if isopropyl will bring that off. If not, acetone might. I might have some acetone here somewhere. Oh no, I do have acetone here. That's going to be more aggressive than the IPA. So let's use acetone to see if we can. Here we go. Another experiment. Another experiment. Can we clean a circuit board exposure material using acetone? It is real close. It is real close. I reckon a 20-minute exposure is probably going to get us there. That's my theory. Okay, let's see if acetone will remove this material. No, it's stubborn stuff. It is definitely stubborn. And it's slowly coming off. Right, I think I'm going to need to get some lye. Right, give me 1 second, guys. I think we're going to have one more shot at this tonight. We're going to have one more shot at it. Give me 1 second now. We'll be right back. Okay, it would seem I no longer have in possession of lye. That's not what I expected. I thought I had some. The mystery of the missing lye. All right, well, I guess we'll just go old school. And we'll use physical abrasion. We'll just use some 120 sandpaper and we'll just sand that off. I think that's what we're going to do. So give me 1 minute as I prepare the surface. This might take a while, looking at this. Oh yeah, this was close. This was very close. This stuff does not want to come out. Oh wow. I really should probably wear a respirator for this. But I'm almost finished. So I'm definitely going to have to dig out my lies from somewhere because that's needed for the final step. Okay, I've got a clean copper clad now, but I don't have a clean hand. So please excuse me as we look to clean up here. One moment, please. Let's turn the laminator back on, and we're going to open up the IPA, and we're just going to just clean everything down a minute because we're going to need to. Right, that goes away. I'm going to need to get me some blue workshop paper, I think. It's a little bit more robust than what I'm using. So, all right. Yeah, steel wool. Yeah, I had a bottle of live crystals. So I definitely don't have any here. So that's a little frustrating, but I had a bottle of it on my workbench, so I don't know where that has gone. It's been a while. It's been a hot minute since I used it, right? So, I mean, okay. We shall start again. We shall not be defeated. The perseverance of the maker. Okay, so let's trim off the excess here. And I'll come back and I'll use these pieces. So there's pieces of this material that you can clearly see have been exposed, which is why I appear to be wasting it. I'm not. I'm just not using the bits that have got exposure marks on them. So, all right. So let's go here. Let's cut there. Let's come up. There we go. And it was stored properly, so I think its age is a factor here. It is old material, which might also be playing into the part of us being able to expose this properly. So, okay, third time's a charm, right? Third time's a charm. So we did 12 minutes the first time, 15 minutes the second time. How long do you guys think that I should expose for the third time? That's a good question. Have I got it really clean? Okay, this is how clean I'm going to get it. Okay, let's put some gloves on. Okay, we're going to get one final cleaning. Okay, you can see all that IPA evaporating. Now this is going to be the fun bit, right? because I've got gloves on. The tape is probably going to stick like crazy to the gloves. But let's see if we can make this work. Okay. Come on. The tape is sticking to the glove. Oh, this is a disaster. Maybe you should have taken the glove off. Don't know. Don't know. Okay, this time we're going to do a single pass through the laminator, and we're going to see how well that does. I think 2 passes is okay-ish. Right. Yeah! Right, okay. So the laminator, is that up to temperature? The laminator is up to temperature. And we'll get a fresh piece of paper, and we will run this material through. You can see where this is lifting. I mean, it'd be probably cool if I had a squeegee or something like that just to get this down, 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 proper down. Proper down. Down with the sickness, down. Right? Okay. Now, the problem I've got here is the tape. The tape is going to be an absolute arse if I'm not careful. So I'm just going to plop this in the middle of the paper, and the tape has just rolled around the side. So I'm just going to stick it down like so. Here we go. Here goes nothing. We're going to do a single pass, and then we're going to have a look to see whether or not that was enough. Oh, right. The things we do for our hobby. So, did anyone comment on how long we think we should expose it for? The first one was 12 minutes. The second one was 15 minutes. I'm thinking 20 to 25 minutes in order to get that done, right? Tell the kids and they're touching the TV, right? Okay, let's have a look at that and let's see if that is. Oh, that's nice. Oh, yeah. One pass is good. I think we might have been running it through too many times. That's real nice. In fact, let me show you on the other camera. That's really nice. Yes, overexposure being an issue. Yes, it is actually. Overexposure is a problem. From like right, so don't consider the laminator. If we're talking about the laminator, no, that's not a major problem. No. If the surface is wrinkled, then it can cause problems. Anywhere that the acid can get in, either through a wrinkle or something like that, then it's a problem. The overexposure on the resin printer, when we actually do the circuit traces, for this type of board, the problem would be on the FPC connector because there's a 1 millimeter pitch on the pins. The pins are staggered, so there's like a 2 millimeter gap between the pins. But the pads, if the pads bleed because there's been overexposure, then that's not going to work, right? It's going to be. There is unfortunately, Robert, there's no temperature setting, but that single pass has done the business. That's like, there's no wrinkles in it, there's no bubbles in it. That is like perfect. So, okay, I think I've got that part of the process down. So I guess it's now for us to set up, and we'll do another pass on the resin printer. So 20 to 25 minutes. Unless you guys, what do you guys think we should do in terms of exposure time? 12 minutes, no go. 15 minutes, we're close. So it's either 20 or 25 minutes, right? You don't want to have any elephants for 3D printing. Right. If you had a DLP resin printer, overexposure would be almost impossible. DLP resin printer? In what sense are we talking DLP? Are you talking about where the it's like a projector, and you project the you reflect the UV light source off the DLP chip? Or are you talking about some of the DLP technology that I might be confusing? Right, so my Sharpie mark has gone, so I'm going to have to put a new Sharpie mark on here. Okay, here goes. I guess we want the... Hey, hello. Nearly knocked my desk over. So we've got to now think about how long we want to expose this for. Right. So 1200 seconds. Or we could do 2 layers at 600. And that'll give, or 4 layers at... Okay, let's do 2 layers at 600. That gives us 20 minutes, right? Or do I want to do 25? What do we reckon? 20 or 25? The projector kind with the Anycubic Ultra, you get a UV really blacked out, so no illuminations by the display, contrast, no straight exposure. Yeah, the only problem you've got with those types of machines, the newer machines, is they've got a lot of safety mechanisms that this machine doesn't have. So, for example, running the machine with the door open, typically they don't like that. Some of them have an ultrasonic resin level sensor, which you're not running with a vat, so it doesn't like that. So there's some hackery that you've got to do with the newer printers that I don't have to do with this, the Anycubic Photon S, which is an older machine. It simplifies this process, but it kind of complicates things in the sense that I've now got to hack the exposure times as opposed to the physical hardware. So 20 to 25 minutes. I think maybe 25 minutes. So 5, 10, 15, 20, 25. So that's going to be what? 750 seconds. 750 seconds by 2 gives us 1500. Is that right? Is my math right? My brain don't do math well. Right, let's see. 1500 seconds divided by 60 equals 25 minutes. Oh, I get better at this. Flipping heck. What's wrong with me? Anyone would think I'm learning. Yeah, they did all of that extra stuff before they just put a heater in there, which is most of the problems with resin printing, right? Okay. So this is now board test number 3. And we want to save. There it goes. All right, so we got 2 layers now. Let's go ahead and get that running. So there's my little mark to register the plate here in the bottom corner. Let's go ahead and plug that in. We will click on enter. I'm just going to back out and just go back in the menu to make sure I've got a fresh read of the card. Board test number 3. Hopefully this one's the money, right? This is the last chance of the night for us to get this to where we want it. I could, I suppose, stick my finger in there and make it think that the thing has dropped, but that could cause a problem later if I wouldn't get in, I'm guessing. Right, okay, so oh my word. So we're gonna figure out whether or not this is going to work, right? So here we go. We're going in for the exposure. The 2 layers at 750 seconds a piece. The reason I did that was, one, I don't know if there's a limitation on whether, like, you know, how long I can have that LED illuminated in the slicer software. But equally, I'm not overly comfortable about running the machine without giving that LED a bit of a break. Yes, it does have a heatsink on it. Yes, there is a fan on that heatsink, but all the same, these things aren't necessarily built for continuous runtime. They're only really expecting to run, you know, maybe 500-600 layers and have a, I don't know, 15 to 20 second exposure time per layer. So the fact that we're running it for nearly 20 minutes, 25 minutes on a single layer, this, you know, that could be pushing the unit a little bit, and I don't want to push it to failure. I'm not scared of having to replace the LED. It's just a job I don't particularly want to do if I can avoid it. So I think the extra exposure time is going to do one or two things. It'll either be It's going to be an issue with that type of LED UV. LEDs have a higher issue of burnout, right? Yeah, exactly. That's why I put the break in there, right? With new, fresh material, I may not have that issue. Yeah, I definitely would need to do a bit of experimentation on exposure with new material. But yeah, I mean, I suppose it could be a good video if my LED burns up and I've got to replace it. Is there a better module that I can put in there, an upgraded module for the Anycubic Photon S? I don't know. Yeah, that would be interesting. So my only alternative would be to like run a bunch of layers. Right, give me one moment, guys. I've got an incoming call. Okay. So yeah, I definitely think newer, fresher material is another variable that we can look at to try and see whether or not we can reduce this issue. But I'm very keen to see how well this actually works. I've got a couple of other circuit boards that I want to put together that I need like hyper low numbers, right? Not worthy of going out to a board manufacturer to have them made. So we shall see. Let's just quickly check that. Okay, I'm still seeing an exposure, so that's good. Should have set a timer really, so I knew how long that's actually been running. So the next experiment is going to be whether or not I can, if I can get this to cure, it will be interesting to see whether or not I can actually get a solder mask to cure as well. That would be pretty dang cool if I can do that. Solder mask has been my nemesis. I've been able to do an okay job using daylight and some printed transparencies, but getting a solder mask to work out well without a CNC mill has been a bit of a challenge. And even with it, I've never really tried to CNC mill, like apply the solder mask, expose the whole layer so it's good, you can cure it, and then put the PCB back into the CNC machine and just take the mask off. I've never done anything like that, and I'd be too worried that I was going to actually damage the pads to warrant doing a job like that. So if I can successfully apply a solder mask using this particular method, that would be kind of cool. That would be kind of cool. I definitely want to see if that's possible. But this continuous runtime of the LED has got me a little concerned, to be honest. But we shall see what it does. But I think we're incredibly close. I think we are incredibly close. Right. Okay. What is next? I guess we need to, let's think about this logically. I still have to drill the holes out to get the pin headers installed. I got a bunch of pin headers that need to go on, and I've also got a dedicated FPC cable that's got to get soldered on. And then once I've got that, then I'm reasonably good to go in the project that this is for. And again, just to recap, I'm building a breakout board that will enable me to interface with a piece of hardware that the original motherboard has died, and we're trying to figure out whether or not we can replace the motherboard with our own control system. And if that is possible, then some of the stock components of the unit can be used. But it's all about whether or not I can figure out how to drive the unit. That's going to be a bit of a challenge. Okay, so what I'm waiting to hear is the rise of the bed, and then the drop again. And then we know we're about 7.5 minutes out from checking to see what has this done. Has this worked? Oh, and so yeah, right, Dimitri. You know the score. You know the score. So yeah, this is going to be interesting. It's going to be interesting to see whether or not we can do that. And it tests my scratch building ability. Dimitri, so if this technique works, I'm looking at replacing the upper and lower light carriage for the Lumen PNP, because I think some of the issues that we had previously with the Lumen is around the illumination for the camera, the upper stage camera and the lower camera. If I can create the boards using this technique, I can get a bona fide PCB with a JST socket on it. That would be nice to like be able to drop in a new module. So yeah, this is a preamble to something else that that we're working on. So it's gonna be nice to see if I can do that. The Lumen is going to be up and running. I've got a bit of work to do on it to make it more reliable. And in fact, you guys haven't seen the Lumen PNP, I'm guessing. So let me give you a little bit of a tour of the workshop here. So you've obviously seen that. What you haven't seen is me fall over, because I got all my stuff spread around the place. This is a Lumen PNP. So if you remember, I talked about a guy called Stephen Hawes who gave me the idea. Well, he actually did this using a Formlabs, and he did a 0.5 millimeter IC using this method, right? So I'm trying it using my hardware and seeing if I can get a similar, if not better result, with not having to hack the firmware, not having to trick the machine. I can just do it, right? But his company, Opulo, they make the Lumen PNP, and this is a variant of the Lumen PNP. PNP standing for pick and place. And this machine, essentially what it does is you have a series of components in feeders. I'm currently decking it out with some new auto feeders for the tapes that I've got for components, and you have a stage where you load your components, and what it does, you load your components and you load your boards, and this machine then will, through these two nozzles, they're connected to vacuum pumps, and it will then grab the component and place it on the circuit board. And the circuit boards that we're talking about essentially is like an array of boards that look a little something like this, right? And they then go into my reflow oven. That then solders the boards that get assembled on here. So this is a small form factor, or small to medium scale manufacturing setup that I'm putting together. There's a couple of projects I've got in the pipeline which I'm hoping to be able to showcase on the channel in the coming weeks and months of this year, and I'm going to hopefully put this machine to good use, right? You shouldn't have to check the machine, just make the STL that has your design on it. I'm not quite sure what you mean there. You shouldn't have to check the machine, just make the STL that has your design on it. I think I've lost context for that comment. Apologies. If you wanna bring with a bit of context, I'll probably be able to answer that with a little bit more clarity. But yeah, that the Lumen PMP, the LCD boards that we built. Should I showcase those boards, Dimitri? Yeah, shouldn't have to trick the machine. Yeah, and that's the thing, right? So a lot of the machines in the early days, they did what they needed to, but as things progress, safety features get added. There's other features that get added, and so on, right? So this is the boards that the Lumen PMP here in the workshop built. And this is a custom built PCB with an ESP32 at its heart. It has onboard circuitry for charging. It has two outputs on it, one for an e-ink display and one for an LCD display. So yeah, these are the boards that were made on the Lumen PMP. And they effectively made this. So this is the e-ink module. It's pretty slick. I'm pretty pleased with these modules. I don't know if this one's charged. Let me see if it is charged. No, this one's not charged. I'll need to charge it, which is a pity. Okay, because we've got an LCD module here. So I'll get that charged up and showcase that another time, right? But yeah, so yeah, this one probably needs a charge also, right? But because it's an e-ink display, it keeps the screen forever until it gets rewritten, and so until that happens, it's got my goofy face on there. But yeah, it's all fun and games, man. It's all fun and games. That was a really cool project to work on. But yeah, we need to revisit that at some point, no doubt. And I'd like to have the Lumen PMP up and running in case it's needed. So that's going to be one of the things I'll be working on soon. Okay, I did hear the lift a drop, so we're inside of the second half of the exposure now. So we'll see how well this actually exposes, right? Should be interesting. And that's the problem now. We've got to wait for this to expose, and then we can hopefully. Oh, can we get a usable unit at the end of it? That's going to be the kicker, right? That's going to be the kicker. So, confidence factor in chat, right? Do you guys think that this is going to work? let's have a like I say, like a straw poll in chat. Do we think this is going to work? Man, I'm hoping so, because it was so close on the 15 minutes and we've got an extra 10 minutes. I just hope that we haven't overexposed it and we've gone too far. But in saying that, we'll know the upper limit of the exposure point, right? And then we can kind of dial it back maybe to 20 minutes. The cool thing about this is that we don't have any fine pitch components on here. I suppose worst case scenario, if I did etch it and I needed to use it, I think the only thing I would suggest is maybe using a Dremel to like separate the pads that are not supposed to be connected. But we'll see. We'll see. Should be no reason they shouldn't work unless there's some type of cutoff in exposure time that we're not perceiving. Yeah, so the overexposure can be a bit of a problem in the sense that it will bleed out. Very much like capillary action with paper and ink, where the ink hits it and it's kind of like spreads sideways. That can happen with these types of machines, or this type of exposure method. It can bleed out and overexpose, obliterating the separation between fine pitch components. So we do have a little bit of tolerance that we don't have like a 0.5 millimeter FPC or IC on the board. So that's good. But that doesn't mean to say we can't overexpose the unit to the point where it's not going to work, right? So we do have that 1 millimeter pitch FPC connector. Admittedly, the pins are offset at 45-degree angles, so it's just a stock lens. I'm not aware of any other lens types, to be brutally honest with you. It's domed on one side, flat on the other, and it's just a stock lens that came with the machine. It's an industrial CO2 laser that came to me that was broken, and I refurbished it into a operational. I won't say fully restored, but I got it working to the point where I can use it. The problem with that machine is that I'm locked into like software that looks like it's from 1995. It's horrific. So I've got a piece of work I'm currently working on where I'm going to be upgrading to a machine with a router controller, and then I can use Lightburn. I can use some more recent software and have a greater level of control over the machine than what I've currently got. Especially when it comes to file types. Old software really doesn't like modern file types. It doesn't know what to do with some of these things. It might well be a DXF file, but it has to be a DXF file of a particular standard. And anything newer than that standard, you run the risk of it completely misunderstanding what's going on. And I very frequently used to get, until I nailed out what was causing the problem, you very frequently would get an issue whereby the vector lines would look like a 5-year-old just come in with a crayon and just scribbled everywhere. So that was a little bit of a frustration. Okay, so we've got something going on here at the moment. The light has gone out, but it's still saying it's got time by the look of it. Ziggy, turn main light off.
Okay.
Oh no, it's still exposing. Ziggy, turn main light on. Ziggy, turn main light on.
Okay.
Okay, I'm just going to check the temperature of this Okay, I don't know whether to call it quits or whether I just let it run the time. Oh, it's got a pause. Is that a pause? No. I'm trying to figure out what's going on. It's not showing anything on the screen. There's activity on the pen drive. But the screen, I thought the camera had frozen, right? But you can see there's nothing on the screen. Do I abort? Do I abort or do I let it run to time? That's the question. Does the machine feel hot? It feels warm. Yeah, it does feel warm. Okay, I'm going to abort. Okay. So let's have a look. I want to run the first board test that I have, because I know that's only like 10 seconds duration. Okay. I think we still need more exposure on this. I mean, it's looking okay, but I think it needs to go longer. I do think it needs to go longer. So I'm just going to do a couple more passes at a shorter duration. Because my concern was that the screen went blank. Yeah, probably is a little bit used to like short duration runs. It's normally 60 seconds or so for the burning layers, and there's only like 3 of those, and the light pulse is off for like a period of time. If it was easy, everybody would do it, right? That's what I keep telling myself. That's what I keep telling myself. If it was easy, everybody would do it. So I'll give it 2 passes at this shorter duration, and then we'll call it, I think. Yeah, exactly. That was my comment about running it for so long and burning out the unit. That's definitely something I don't want to do. Okay, this is only saying it's got like 2 minutes on the layer. Okay, there it goes. Okay, give it 1 more pass of that, and then we'll call it. And then we'll look to clean it, and hopefully that'll come good. Oh. It's going to be interesting. All right, let's get prepped, ready to do the cleanup. Yes, no, don't you know? If you saw my last video, right? I have squirrel moments. I was never intending to build this keyboard, and I did. So yeah, you're giving me ideas here. You're giving my squirrel tendencies, like I'm fighting it. I'm fighting it. Stay on target. Stay on target. Okay, we should be coming to the end of this now. And then we can see the fruits of our labor. Did it or did it not work? But yeah, you're giving me like, oh, do you know what? Do you know what? Oh, thank you so much. I appreciate that. Unfortunately, now I'm going to learn how to touch type. Like, I'm going full on immersion. So I'm going to get myself a KVM, and I'm going to switch between my work laptop and my home PC. And I'm only going to use that keyboard. There we go. That's done. That's done. This is it. Did it or did it not work? Okay, first glance looks good, but the last time we first glanced it, it looked good also, right? So the question now comes is, will it develop? Will it develop, or will it just go to poop at the last minute, the last hurdle? So I'm highly likely at some point to be making custom keycaps of that keyboard. Right now, I'm shaking that keyboard down. Oh, where's the end of the tape? I've lost the end of the tape again. Sure, somewhere. Is that it? Is that it? Have I found it? Yeah, I got it. Oh, man. Okay. So yeah, I'm looking at making some custom keycaps for that. That would be pretty cool. Okay. There is our exposed PCB. The question now comes is, will it develop? So in it goes. Let's not mess around. We're on the clock. Well, I'm on the clock. I got more to do tonight, but not for the stream. Got some IRL stuff to take care of. Now, I did use warm water originally, and it's gone cold now. So I don't know whether or not this is going to develop the same way, or whether the warm water helped it develop quicker. Don't know. I think it is developing, so that is good. And the question is did we get enough exposure time for this to develop, to expose fully? Not overexposed, but expose fully. Soak a second. Now, my confidence is actually a little bit higher this time around because I'm not seeing the main exposed area changing color. So I think we've hit peak exposure. I think we've got there. The question is whether or not we've overexposed. I think that's what we're asking at this point. In fact, I'm going to get a brush, a soft bristle brush, to see if we can just get this to clean up a little bit faster. Oh, this looks good. I'm wondering if we have overexposure. No, please don't do this to me. That would suck if we've overexposed. I think we might have. Don't know. Yeah, I did. I did that on a piece of paper, and the results that we got were somewhat mixed. We thought we had the right exposure times at the beginning of the stream. That is actually what we did. I think we're overexposed. Oh, you son of a gun! Are you serious? I may come back through here with a multimeter to see if we are actually overexposed. I think we are. I'll show you a close-up now. Okay, so there's the board. Let me zoom in. So I think the gaps between the traces, the isolation traces, I think we're overexposed. You think I was good at the first abort? Probably. Looking at this, I think we may have already been over at that point. So I'm going to let this sit. I'm going to let this sit in here and just let it soak, let it develop, and see whether or not, if a soak over time, will let those isolation traces develop, right? Well, with the film that I've got, I do, Dimitri. Would seem I've got an issue with it, but anyway, that's another story entirely. I'm going to call it here. Thank you so much for hanging out. I will document the progress of this. Let me see. I'll definitely document it in Discord, and I'll probably post it on YouTube community posts. There you go. Perfect. Right then, guys, I'm going to call it now. Until next time, have fun, be safe, make something cool, and I will see you in the next one. Until then, bye for now.